So an interesting phenomena about the Earth-Moon system that you've known since, well, I don't know since when. Maybe this is the first time. In any case, it's the phenomena of the Earth-Moon tidal lock where the Moon and Earth, actually the Moon is facing one side toward the Earth all the time. So what is the reason for that? I gave you some choices here. It's a little quiz, a little pre-quiz. Either it's not spinning, it's coincidental, the man in the moon wants to smile on us, of course that's the best choice, or something else. Well, if you conclude that it's not spinning, and you cause the moon to orbit the Earth, you will notice that as it makes one complete orbit, you see every part of the moon. You see all around it. So it actually is spinning, and it just has to, the interesting thing is it has to rotate exactly one time during its revolution time in order for this to work right. So that when it gets back to its original position, it's rotated once as it's revolved, and it's always had one face toward the Earth. Well, the Earth then goes from this kind of round, the moon goes from a round object essentially to highly exaggerated oblong shape here. So we are looking for the something else, and the something else is the tides, as we've already discussed. All right, so how does this work? So here's the Earth, and we'll draw a line from the Earth to the moon. There's the moon. That's stretched out from the tidal effect of Earth. And this is the center of mass of the moon. However, mathematically, this is not where the Earth tugs on the moon, because the Earth's gravitational field follows an inverse square law. So there's a gradient of G field across the moon that's stronger in this region toward the side closest to Earth than the side further away from the Earth. Because of that inverse square law, it's not linear. It places what's called the center of gravity in front of the center of mass, or toward the Earth. So this is where we can think of the Earth tugging on the moon. Effectively, it's exactly true. It's where the Earth tugs on the moon. So it's different. That point is different than the center of mass because the G field is stronger on the near side. It's actually the average location of the G field. And if that's the average location of the G field, then it's also the average location of the gravitational force. So it's the center of gravity. Now that really has some interesting implications. Let's consider the arc of the orbit of the moon. If there's no spin, a little while later, and there's some details here that would need to be addressed with calculus thinking, differentials, but for our purposes for now, a little while later, there's the moon. If it hasn't spun at all, it's oblong in such a way that the center of that center of gravity point we're talking about is offset from the center of the mass of the moon. Okay, so there's some details, and I'm not going to worry about here. And if you're thinking about, if anything, I could anticipate that your concern would be, well, why isn't the shape of this lined up with this again? Well, it does do that, but it's delayed a little bit. So in a differential sense, a little while later, if it's not rotating, the moon has orbited a little bit, and it really, this bulge is not lined up with the Earth. So the Earth is tugging on this point here, essentially. And if it does that, you can imagine what happens to an object when you put a force on it that's off-center. Now, I can't demonstrate this for you, but if you give, say, a meter stick or a yardstick, if you give it a shove right in the center, at the center point of it, the whole thing accelerates uniformly, but shift your finger off a few inches and give it a shove, and you'll see it rotate. So when we pull on it here, this is going to cause there to be a torque that tries to spin this whole thing, from our point of view here, counterclockwise. It's going to try and rotate it around. And really what that's doing is trying to line up the moon with the Earth once again. So a torque is produced, causing the moon to rotate back to align itself with the Earth again. I mean, if the moon is spinning too fast, then instead of being oriented like this, it'd be oriented like this. So we have this oblong shape here, and the Earth would be tugging on it like this and causing it to rotate clockwise. But as it is in my illustration, it's rotating it counterclockwise from our perspective here. So that's why one side of the moon faces the Earth. If there's any deviation in what goes on here, if the moon is trying to do anything else, it gets out of alignment and the Earth torques it back into position. Now the moon is doing the same thing to the Earth. We already mentioned this in the previous video. So the Earth's rotation rate is actually decreasing. It's trying to lock the Earth to it as well in the same sort of way. And this causes the Earth to decrease in rotation rate by about 4 microseconds a year. Hope you found that interesting.